Hi guys, welcome to this video. So in this video, we are going to see some basic tools. Like in previous video itself, like we have seen basic tools like um, sketch assembly and what are all the tools available inside the sketch. And sorry, like we have not seen assembly, right? So we have seen extrude there, sketch and extrude. So we have seen what are all the tools available inside the sketch and inside the extrude. So let's use another some more common tools like expect like sketch or extrude. So let's see what are all the tools available here. So at first I'm going to open this like the last session we have created a part right as a beginner tutorial. So I'm going to open that part. So this is what we have created at our last session. So here I forgot to tell you about these views. So this will be automatically taken as a shading. If you need to view this model as a shading with reflections, you can see the reflections and shadows. So it will look like a realistic product. Okay. So you can change it as a shading with edges. So it will show the edges. So you can see in this bend there are so many edges. Okay. And then you can go for no hidden line. Okay, so the hidden line will not be viewed in this drawing. If you go for like a hidden line feature, you can see it's like a 3D sketch which we have done like in like while we are studying, we will draw some 3D drawings like 3D cubes, something like we will draw the back lines also. As you can see, we can able to see the back lines also like this lines also. So this is called as hidden line. Okay, and the wireframe. Wireframe is also similar to the hidden line, but if you click on this hidden line option, the hidden lines like these back lines will have a like a low intensity, low weight line. Okay, as you can see, these lines will be bold, where these back lines will be very thin. Okay, so it will be separated as a thin and thick lines where we can identify whether it is a hidden line or it's a line like which we are going to view. So here, if you click on wireframe, you can see every lines will have the same weight so that we can't able to find whether it's a hidden line or a normal line. Okay. So these are all the views that I forgot to mention in that last video. So I recommend you guys go on with the shading with edges while you are doing that model. But after completing the model, you can go for shading with reflections for a good viewing your model. Okay. So now I'm going with shading with edges. Now, at first, now I'm going to delete all these sketch. Okay. Now let's continue with a new part. Okay. Now you can see the planes and coordination system here. Let's go for the standard view, standard orientation. So now we have seen a sketch tool and extrude tool in our last video. In this video, let's see the tools which are available in this model tab. Okay, like a plane, axis, point, coordination system, and revolve, sweep, and what are all the sweep available under this sweep option, like a normal sweep and helical sweep. And then swept blend. Swept blend is it contains like it took over 30 or 40 minutes to tell the basic of this sweat blend. Okay, so I will put separate video for this sweat blend and this draft tool. Okay, in this video itself we can see the whole option: round, chamfer, shell, rib, pattern, and mirror. I think this mirror option is explained in the last video in inside the sketch itself, and I'll show you how to use this mirror tool after extruding our sketch as a 3D part. Okay, so let's start our session. So here, at first, let's go with plane. So I'm going to draw, like I'm going to extrude a rectangle first of all to create a plane. So for easy understanding, I'm going to draw a rectangle like with 100 as a length and 50 as a height. I'm going to click OK. Now I'm going to extrude this as a symmetric extrude as a both side extrude, and I'm going to enter a value of 20. So that will be the extruded value. As you can see from the center plane, as we entered symmetric extrude from here to this end, it will be the value of 10, and on the other end, it will be value of 10. So the total value will be 20. Okay, so now let's click on OK. So we have created this sketch and extruded by the reference of the front plane. So we have created this sketch on the front plane only. Okay, if you need to create another rectangle, with a distance of, like, if you need to create this same rectangle on this surface, how you can do that? Okay, so there will be option known as plane. Okay, you can create n number of planes here. So if you click on this plane option, you can see the datum plane pop-up window has been shown here. For that, we need to select a reference plane on which plane we are going to create. Whether, like, you have to create a plane like taking reference as this front plane, or this right plane, or this bottom or top plane. Okay, so at first you need to select the reference plane. So I'm going to select this front plane as my reference plane. You can see the arrow mark here, it is showing like in this direction. If you enter a value of like a translation value, it's nothing but the distance from this reference plane to the new plane which we are going to create. Okay, so as you can see the arrow mark here, it is moved towards like this side. Okay, so I'm going to add a value of like I say 100 here. As you can see, at the distance of 100, the front plane is replicated again. Okay, so this will be our new plane. Okay, and uh, and also you can drag this, and you can also manually adjust your plane feature here. Like, instead of that, if you need to flip the direction, you can directly click this arrow mark, and if you enter a value of 0 first, let's see, and then if you click this arrow mark and if you enter a value of 100 again, it will be moved on the other side. But before itself, we have to assign the value, or else you need to give some negative value for that, so that only it will be moved on the other side, where it will be taken as a positive side. If you add a value of 50 now, it will be moved on the other side. Okay, so this is how you will create a plane here. So let's take a value of 70 and let's continue with this plane. Okay, and then you can click on OK. So this is how this plane option will work. If you need to create this rectangle again, you can directly click on this new datum plane. As you can see in this model tree, you can click on this plane. You can directly go for sketch and sketch view. Okay, like I think I have explained to you about this project tool, right? If I forgot, like, I'll explain you again. Project tool is nothing but, you can see in this new plane that we have created. In this plane, there is no sketch which has been already there. In that back plane itself, there will be a drawing. Okay, if you go for a sketch view, you can directly project that line into your this newly created plane. Okay, so we have clicked this line only, but you can see it is projected on the plane that we are created. Okay, so like this you can project this. Okay, let's close it, and then now let's click on OK. This is how this project tool will work. And now you can extrude it as a symmetric extrude and the same value of 20 which you are given for this previous rectangle, and then now click on OK. So this is how you can use this plane tool. Okay, so let's delete all this and let's see the next tool here. Let's go for the standard orientation. So here we have done the plane tool here, and then now let's go for the axis. For axis, yeah, if I say like yeah, wait, let's go for standard orientation. So this is our front plane, like, right? If you need to create an axis, okay, you can't see any axis here. So if we click on axis, it will be directly taking this front plane because we have selected front plane here, right? So it will be taken the front plane as an axis. Okay, like in between the front plane. Okay, you can also keep normal, you can also keep this through all option. Okay, in this through all option, you can see like it is like a parallel or perpendicular face here. You can directly go for normal, and now you can adjust the dimension. You can drag this to this edge, and you can drag this to the top, and you can assign any values here, okay, like a distance of 10 or a distance of 50. So you can move your axis like this, or else you can directly drag this point and you can directly move anywhere else if you need this axis. Okay, so this is how this axis tool will work. Like if you need to know deeper about this, you can create an extruded part and then you can create your own axis by yourself. Okay, so this is how this axis tool will work. Okay, point is nothing but it's whether it is similar to the tool which you have discussed in this previous video itself. Like inside that sketch tool, you can also see the point option, like you can see here. So the same point tool will be used here, but this, like if we use point tool on the sketch, it is only visible on the sketch tool only. If we use point tool here, where it will be visible on the entire part. Okay, and then coordination system. So next, the coordination system is nothing but you can see when we hide all these except this coordination system display. So this will be our coordination system display, whether what is x-axis, y-axis, and z-axis. Okay, so let's turn it all on. Let's go for the standard orientation. Like I'll give a simple example like how to create that. For that, I'm going to delete this axis. So let's go for the front plane. We can directly go for extrude. The SketchUp pop window will open. We can go for sketch view. Here I'm going to draw two concentric circles like this and say okay. Now I'm going to extrude this to a value of 300. Okay, then click on OK. As you can see, the coordination axis is placed in this midpoint only. Like this coordination axis, like a coordination system, like this tool will be only used when you are using a cabling option or a piping option or like a welding option. Like welding option itself, it is not like it is not mandatory used to use this coordination system, but in both piping and cabling, like this coordination system is very mandatory to use. Okay, so for that, if we need to create any coordination system, like we can click this coordination system. It is asking us to select the reference. So I'm going to select this circle as a reference, so the midpoint will be taken as this coordination system, and we need to select the face and which face we need to place this coordination system. So I'm going to select this face. Okay, I'm going to select it again. Wait. So at first we need to select this circle, so it will be placed center. We have to go for orientation. Okay, I forgot about that. So we have to go for orientation, and then like we have already used this extrude tool to find the center point where the z-axis will place. So we have to project our x-axis. For that, you need to select this, and you have to like select any angle or like I'm going to select this face. As you can see, the x-axis on the top. You can directly flip that towards down, and you can also flip the z-axis towards back. Okay, so this is how you will work on this. But as you can see, the x-axis will be in this like uh, like in this horizontal way. So I'm going to change this x into y, and you can see the x-axis is in horizontal, and I'm going to flip this y-axis towards top. And now you can see this is x, and the vertical portion is y, and the back side is z. Okay, so now let's click OK. As you can see, our newly created coordination system, as you can see in this model tree, it is view here. Okay, so this is how you will use this coordination system. So basically, it is only used in piping and cabling options. So you don't want to create coordination system for all your trigrams. Okay, it is mainly used in those parts only. But while your guys are doing any piping option, it is mandatory to do that. Okay. So the next one is sketch extrude, like we have seen in before itself, like in the previous video. Like if you have not seen that video, kindly see that part one and then come to this video so that it will be very easy for you to understand all the tools. Because uh, if you have not seen the first video which I have released, like a part one basic tools, if you directly watching this part two, it will be very hard for you to understand. So come by order, so you will get to know about more about what are all the tools available in this Creo. Okay, if you have any doubts, your coordination system part is not working, you can directly comment, I will reach you. Okay, so the next one is we'll go for Revolve. So for that, I'm going to delete all these and I'm going to start up fresh. So it's for standard orientation. So this Revolve tool is nothing but like if you need to create any part, like how can I say, like you can take example of a ball, right? So if you cut the ball on the center plane, okay, so if you separate the ball into two sides, where you can see the left side and the right side as the same dimension. Okay, so I'll tell you how this works, and then you will be able to see, because I can't be able to explain it through words. So I'm going to select this front plane and go for the sketch, and then go for the sketch. So here, let's create a ball itself at first. Okay, I'm going to draw an arc like this, and I'm going to make it as a round feature. Okay, I'm going to change this dimension as 0. So okay, so we have created one side of this ball. Okay, so we can complete this sketch like this. So now you can see we have created only one side of this part. So if we click on this revolve tool, it will be automatically revolved all around the part. Okay, so let's go there and we can see how that works. But if you are using this revolve tool option, you first need to create a center line in which the sketch or part get to be rotated. If you click, if you create a center line like here, your part will be rotated based on this center line. So where you are placing the center line is very important. Okay, so I'm going to place the center line like this as a vertical center line, and then I'm going to click OK. So here, as you can see, we have done only one sketch at the one side. So you have to select this sketch, and you can directly like go for this revolve option. As you can see, like we have created only this side only. As you can see, it is rotated all around the part, and then we have created a circle. Okay, so this is how this revolve tool works. You can also drag like this by using this point, or else you can also add a angle for this. When it comes to 360, it is a complete part, or else wait, if you are 270, it will be like 1 by 3, and then if you are 180, it is off of the part, and if you are 90, it is like off and off. Okay, so this is how this revolve tool will work. So let's say 360. Okay, in this also you can make it as a surface. Okay, and then you can see the symmetric extrude, or like up to the surface. Okay, so I'm going to make it as a solid, then I'm going to click on OK. As you can see, our part is created. This is not only for the circle. Okay, I'll show you. I'm going to delete this revolve, and I'm going to edit the sketch. Go for the sketch view. Here, instead of this circle, instead of this ball, let's say let's say a bottle. Okay, you can see the bottle. Like if you separate the bottle into two, the both the sides will be same, right? So let's create a bottle. Like how we can create like this. Okay, like I'm not adding any kind of dimension, just to teach you how to use this tool. And then I'm going to complete this sketch. Press escape. So I'm not going to add any dimension, just clicking OK. Now, after selecting the sketch, you can go for revolve. As you can see, our part is created. Okay. So this is how this revolve tool will work. You can also move like this. You can keep like this, or you can take as a full revolve tool. So this bottle will have a it's a kind of surface, like it's not a solid. So we can also use thickness for this tool. Go for this, and I'm going to enter a value of not 2. I think we have not find a value, right? So instead of doing this also, like I'm not going to do this. Just click on OK. As it is a solid part, you can directly go for shell. Okay, you can directly go for shell. Click the surface, and you can see it is becoming hollow. Now you can also drag this, and you can adjust this thickness, or else you can also manually add a value here. Okay, so this is how this shell tool will work. Shell is nothing but making the solid part into like a like uh, inside, like we are creating some whole feature, or it's not nothing, like we are creating some hollow feature inside this part. Okay, it's not getting filled. Okay, it's like an empty part. Okay, so this is how we need to use this revolve tool. So now I'm going to delete all this, and let's go for the next tool. Let's go for standard orientation. So for the next tool, it's nothing but sweep. So before doing that sweep, we have to create a sketch. The like sweep is nothing but there are two type of sweep. Like one is normal sweep, and another one is helical sweep. Okay, helical swing, like normal sweep is nothing but we have to create a line. Like you can use a spline, like yeah, you can use spline, or you can use a line tool or rectangle tool or circle tool. Okay, like after creating your sketch like this, like we are going to create some dimensions for this line. Okay, so you can go for this normal sweep. After selecting this line, you can see the start point will be like this. The arrow is towards inside this part. Okay, we can go for the sketch, and after clicking sketch, as you can see, this x and y axis is placed on the start point. If you go for the sketch view, the sketch view will be placed on the start point. Okay, so at the sketch view, you can draw a circle, or you can draw a rectangle, or any other thing. Okay, I'm just going to draw a circle. Let's assign this value as a 30. If I click on OK, as you can see, the sketch part has become based as like a 3D part, has converted into a 3D part. Okay, and then let's click on OK. So this is how this sweep tool will work. Okay, so let's delete this, and let's move on for the next tool. Like next sweep tool, standard orientation. Now let's go for the helical sweep. Helical sweep is nothing but it's like a kind of spring view. Like you have seen spring, right? Like how the spring will look like. Like it will be look like a circular part. Let's see how it works. Okay. First, I'm going to select the front plane and go for the sketch and go for the sketch view. Here, at first, we need to create a line, like how, like it's like nothing but we are going to assigning the length of that spring. Okay, now let's I'm going to draw a line, and I'm going to enter this total height as 500 and this height as 250, where it is placed on the center, and this distance, okay, let's keep as 60. I'm not going to add any more values here. So then we have to create a center line, which we have created. Like for Revolve tool, we have used the center line light. So here also we need to create a center line. So based on the center line, the circular ring will be created around this center line. Okay. After creating a center line, you can directly click on OK. And then now you can see our sketch has been created. If you go for helical sweep option, you can see the references, like we have to select the helix profile. So for that, we need to select the sketch. Like this is the profile that we have created, so I'm going to select this line. After selecting this line, you can see the arrow mark is towards downwards, so the start point will be the top point, or else you can directly flip like this, so the start point will be at the bottom. So I'm going on with the top side. So after selecting this line, you can directly go for the sketch. So the sketch view, as you can see, it is like we have seen in the sweep tool itself. Like at the start point itself, it is taken as a x and y axis. So we have to, yeah, so we have to draw whether we need a circular spring or triangular spring or a rectangular spring. So I'm going on with the circular spring. So here I'm going to add a dimension of let's say 15. Okay, and then I'm going to click on OK. As you can see, the spring is created. Okay, like if you want to edit the sketch which we have done before, so you can directly click on that sketch tool and you can go for the sketch view and you can also edit this dimension as a value of 10. So I'm going to change it as like a little bit smaller. Okay, so this is how it works. Okay, this helical sweep option. So in this, okay, you can see the pitch value here. Like you can think you guys can't be able to see that. You can see a pitch value here. We zoom in, you can able to see. You can see pitch value. Pitch value is nothing but the distance between these springs. Okay, like you can see some distance here, and you can see some more distance here. Okay, so this distance is nothing but the pitch value. Like I will take this pitch value. If you don't have any dimension for this spring, you can directly go on with your own dimension. So we have assigned this circular diameter as a value of 10. So I'm going to value of 20 means, as you can see, it looks like a uniform spring, right? So in this spring you will see there will be a like a constant distance, constant pitch value of 20 20 20 20 20. So the spring looks like a normal spring. Instead of that, like if you see some more springs at the top, it will be the pitch value will be very low. You can see these springs will be near to each other. On the midpoint there will be some spaces, on the bottom also it will be very close to each other. So for that you can go for the pitch. As you can see, this entire helical sweep feature has only one pitch, which is nothing but the location start point till the end point. Okay, there is only one pitch. You can also add another pitch where it will take the end point. So at the end point also we are going to have the same pitch of 20. If we add another pitch, it is telling us to create location type. Okay, you can also add a value as a 250 means it will be center, or else you can add a value of 100. Okay, and here it will be 50. Okay, and then we can add another value and to the distance of like 100, like 300. Okay, it will be also 50. Okay, as you can see here, from here till here it will be a different pitch value, and from here it will be a different value, and from here till here it will be a different pitch. Okay, you can also not, if you are can't able to create or assign any kind of value, you can also directly go by the reference. Okay, if you need to drag like this, you can also drag like this. Okay, you can also drag like this. So this is how this pitch tool will work. If I think you guys not able to see any difference between these two pitch. Okay, when I'll reduce the value, you guys can able to see clearly. I can enter yeah, 5 here. Here also 5. You can also edit this value based on this ratio. So, but I'm not sure about that, so I'm going to use this like by reference itself. Okay. So now let's click on OK. As you can see now, let's turn off all these displays so that it will be very easy for you. As you can see, at the top part, it has very low pitch, so it is one on one, like near to near. And middle, it has more pitch value. On the bottom, it also has more pitch value. Okay, so this is how you can edit this pitch value. If you are not clear with this like helical sweep tool, I can put another separate video for that. So you can comment below if you are not like not clear with this explanation, because in this video I have to cover all these tools, right? So it will take more time for me to create this video. So I'm just like teaching you guys the overview of the tool, like how this tool will work and what's the purpose of this tool. If you need deep explanation about this single tool, you can also comment below. I'll put another video for that. Okay. So for swept blend, I will put separate video as it has some more information, so you have to spend more time on that. So I'll put on okay, another video as for swept and also for draft. Okay. So now let's delete the helical sweep option, and let's turn on all these display planes, and then now let's go for the standard orientation. So here let's see the round, like round hole chamfer, and we have seen shell here and the rib option. Okay, so at first for inserting round chamfer hole we need to create a part before itself, so that only this option will be enabled. So I'm going on with the center rectangle like this, and I'm going to extrude this. This value is enough for me. So this will be our part means. So here we need to add a hole. You can also draw a circle if you're working for any organization, or if you're submitting a project, you need to create some standard for the tool. If you click on this whole option, you can see whether it is a simple type or a standard type. Okay, if you click on the standard type, you can see there will be a thread type. So this will be the standard, like ISO standard, UNC standard, UNF standard. So basically we will use ISO standard. Okay, so and then you can see the screw size, like M1, M2, M3, M4, like up to M68 into 6. Okay. So at first you can see the placement option here. There is no item has been selected. So we have to select a surface on which we are going to create a hole. So okay, after selecting this, you can directly, like you can close this. Okay. You can directly select the thread which you are going to create. Okay, I'm going to create this big thread. Okay, so after selecting that, you can see the offset reference. You have to select the offset reference. So let's go for the front view, so it will be very easy for us to drag this down. You can see this two parts here. It's nothing but we have to drag this part, and we can assign the dimensions. Okay, we can drag this to this edge, so you can see the dimension, like from this midpoint to this. Okay, and you can drag to this line, and you can see, or else you can also drag this up to this midpoint. Okay, since I have not made this rectangle with my exact dimension, I'm just leaving it. Okay, so now if you can see here, the thread has been created. So you can also adjust the length of the thread, like if I entered 100 value here, as you can see the thread is created to a value of to the depth value as 100. Okay, if you need to create this thread for the through all option, you can directly click that, so it will be like created as a whole. Okay, so I'm going to create a value of 150. Okay, so this will be the depth of the thread, and you can also select whether it's a counter sink or counter bore. Okay, so I don't want it, so I'm just unclicking it. Like you can also use this option for counter sink and counter bore. So now so that's all. We have created this whole feature, and you can directly click on OK. After clicking this whole feature, you can see, like we have used M68 into 6 thread as a ISO standard, as a tapper of 100 mm, like 62 distance. Okay, 62, and like it's like 150. Like we have mentioned the depth, right? So this symbol is nothing but the depth. Okay, as a 150 as a depth. Okay, so as you can see, it has some tapper. So it is mentioning, if you can see here, if we go for sectional view, you can be able to see the tapper option. Like yeah, let's go for the section view, so that you can see there is some tapper, because we have created standard thread, right? So it will be like a tapper feature for that. So we don't want this as a section theme. Let's go for the model again. Let's see what are all the other features. So round and chamfer, we have already seen, like in before video itself. We have used that's round and chamfer tool in Sketch, right? So the same will be happened here. So round, you can select this edge and you can drag like this, or else you can manually add a value here for that round feature. Okay. So chamfer is nothing but you can click on this chamfer, you select this edge, you can drag like this, or else you can add a value here. Okay. So this is how this round and chamfer tool will work. Or else, like let's delete this. If you have more parts to round, okay, so for this part you can have only like 1 2 3 4 5 6 7 8 and 9 10 11 12, like only 12 sides. So for that you can select manually like all these edges and you can make round. Or else if you have more edges, like how can you do? So that's like auto round feature here. Like here you can see convex and concave. Convex is nothing but like we are creating round feature for the external surface. Concave is nothing but for this internal surface we will create round feature, right? So for that we need to use concave. So I think concave is not like it is not used here. So if I just assign a value of 10, okay, and if I click okay, you can see all the edges have been rounded. So this is how this round tool will work. And the same for the chamfer. Okay, like edge corner or edge chamfer or a corner chamfer. Like let's delete this auto run feature. So edge corner, like edge chamfer is nothing but like this edge. If you are selecting this edge, it will be become like for these two face only. Okay, if you go for the corner chamfer, all the three sides will be. So for this, we can't able to select a line. We can able to select only the point. As you can see, it has been chamfered for all the three sides. You can also drag like this for each and every sides, or else you can have separate value like 50, 40, or 30. Or else you can also add the same value for all the sides so that it will be very look like a even manner. Okay. So this is how you can use this round chamfer tool. So the next one is rip feature. Okay, for rip feature, we can't implement here, so that I'm going to yeah, I'm going to create another sketch. Select front plane, go for sketch, and go for the sketch view. So yeah, here like I'm going to use Revolve Tool again. I'm going to draw a center line, and yeah, so I'm going to create a part like this. Go for the Revolve Tool. Okay, then click on OK. If I need to create a rip feature like this here, okay, so how we can use this rip feature? So here we need to select this plane and go for the sketch and go for the sketch view. At first we need to create a line like how our rip is going to take place. So I'm going to create a rip from this edge to this edge. Okay. So I'm just creating a sketch and then I'm going to just click on OK. As you can see, our sketch is created, but our rib is not created. So you have to go for this profile rib option, and for references you need to select this sketch, and you can see the rib part is created. You can drag like this. As you can see, this rib feature will taken on all this circular part. Okay, you can drag like this, or else you can add a value here like 40, yeah, and then click on OK. So this is how you can create a rib feature. Okay, so the next one is mirror. Mirror is nothing but we have created a mirror option in the sketch itself, like in before video. So for this part, if we need to take mirror means you don't want to create any center line because it has contains like planes, right? Front plane, top plane, and right plane. So you can directly select this profile rib and you can go for this mirror option. Or else if you click this profile rib, you can also see here mirror option. You can directly click this, or else you can also click here. If you go for this mirror, as you can see, we need to select the mirror plane. Okay, mirror plane is nothing but if you like in which plane you are going to take mirror for this profile rib. If I selected this plane, as you can see, this rib has been created on the other side also. This is how this like yeah, this mirror tool will work. So now I'm going to delete this mirror tool And I can explain in this tool itself like how to use this pattern tool. As you can see, it is not get activated because we have to select a part for that. So I am going to pattern this rib. Pattern is nothing but we are going to create this rib for like if I need to create one more rib on the opposite side, we can use mirror tool. We can directly mirror this by the center plane, and we can directly create another rib on the other side. But if you need to create like 1, 2, 3, 4, 5, 6, 7, 8, if we need to create like this for eight numbers, how we will use this mirror tool? So it will be very difficult. So for that only we can use this pattern tool. At first we need to select the part which we are going to use as a pattern, and for the same here also you can directly click here for pattern, or else you can directly go for this pattern. If I click this pattern, as you can see, there are various options available in this drop down, like dimension pattern, direction pattern, axis pattern, fill pattern, table, curve, point. Okay, so if you have circular parts, you can directly move on with the axis pattern because you have axis here, right? So if you don't have axis, you just have a rectangular 3D. Just imagine that you have a rectangular part. Then how you have to able to find the axis of the rectangle? It's very hard, right? You need to create another axis for that, and then only you can be able to mirror that or pattern it. Okay, so for that can use a direction pattern. After clicking on the direction, you need to select the direction in which direction you have to mirror your part. If I select this direction, you can see one part is created. It's nothing but number of members, like how many members you have to pattern it. Okay, if I need to create 10 numbers, you can see our part is created like this, like 10 numbers, like you can see which is close to each other. So you can add a spacing here, like if I have spacing of 20, you can see it is created like this. Also let's make it little bigger, like a value of 50. If you click on this value, so I think it is not get regenerated because we can't be able to do this by dimensional pattern because there is no solid part here. So this profile rib will be will be floated on this sheet. Okay, so it will be not get generated. So we can directly delete this. Okay, okay. So now let's create rib again. I think the sketch is available, so we can directly go for the profile rib. And here I'm going to add a value of 20, and then click on OK. Okay. So if we need to create this rib for the circular part, we have to go on with the axis pattern, right? So I'm going to select this profile rib, go for pattern, select axis pattern, and now here I'm going to select this axis. As you can see, it has taken as number of members as 4 as a default value. Now I'm going to create this as 8. Okay, and this angle is 360 because we are going to create this as 360. If because this angle is 90, right? So there will be distance of 90 for each. For that, for a direction pattern, we need to add a spacing value for that. For axis pattern, we need to add an angle value. If I click on 360, as you can see, for 360-degree angle, we have created our parts. 360 divided by 8 will be the distance between these parts. Okay. So if we click on OK, you can see our part is patterned like this. Okay. So this is how you will use this pattern tool. Okay. Okay, so I think we can also create another rib. It looks good. Okay. Now I'm going to draw a line like from yeah from here till here, and then I'm going for a rib feature again. Profile rib as this axis towards upwards. I'm going to flip it toward downwards so that only the rib will be created on that particular direction. And I'm going to add the same value of 20. Okay, it looks good. So now I'm going to pattern it again as an axis pattern. Select the center axis and then put the numbers as 8 again, angle as 360. Okay, or else you can also add like two more numbers like 10. Okay, we click on OK. So we have created our part. Okay, so this is how you can use this pattern tool and mirror tool. Okay, so if we need to create this part, or like we can also use some simple mirror tool here. Okay, like we can select all these sketch, revolve, pattern, okay, all this, and you can mirror this part toward this center plane. As you can see, it is created on the back side. Okay, but you can see for this the mirror will be fade because we have imported more, like we have created two patterns, right? So it is very hard to mirror those parts. Okay, so you can use, like you can create this part and you can also mirror that, and then you have to create this rip tool and you can also mirror it. Okay, so that's all guys. So we have seen many tools in this video, like planes, axis, point, coordination system, sketch, and revolve, sweep, hold, round, chamfer. So we have seen many parts today. So I will upload the next video for the swept blend and the drafting tool and the boundary blend and what are all the features that we have left in this session. I will try to put it on the next video. And on the next video, like I have like received some question like how to create or how to format our drawing sheet if you don't have any A type format sheet, and how we can create that sheet manually, and how we need to create or how we need to format the text which is under the drawing sheet. So I'm going to upload new video on that, so stay tuned. I will upload that as soon as possible. So that's all guys. Thanks for watching. So if you want more videos related mechanical engineering or any other content, so you can comment below. So okay guys, we'll see you in next video. Till then, bye.